Assalamualaikum and good day. In this video, we will be covered on microstructural changes. This is the fourth part of iron-iron carbide system video. On the first part, we already covered on solid phases. The second part, we covered on phase transformation reaction. The third part, we covered on allotropy transformation. And the last one we cover in this part is microstructural changes. For microstructural changes in iron-iron carbide phase diagram, we will cover on Eutectoid only, because for eutectic we already covered on binary eutectic phase diagram. I hope you can study on eutectic in the binary eutectic phase diagram so that you will understand the microstructures for eutectic, hypoeutectic, and hypereutectic. For iron-iron carbide, we will cover on eutectoid, hypoeutectoid, and hypereutectoid. To make you better understand, I show you in the phase diagram. For hypo and hypereutectic, we already covered on binary eutectic phase diagram. So for iron-iron carbide phase diagram, we will be covered on hypoeutectoid and hypereutectoid, and also eutectoid microstructure itself. Eutectoid occurs at composition of carbon in iron less than 2.14% of carbon content. After 2.14%, the microstructure is on eutectic. Hypoeutectoid occurs at composition of carbon less than 0.76%. More than 0.76 until 2.14, the microstructure will become hypereutectoid. So at eutectoid point, we form eutectoid steel. When alloy of eutectoid composition at 0.76 weak percentage of carbon in iron is cooled slowly, it forms a lamella or layered structure of alpha ferrite and cementite. This structure is called pearlite. Please remember, ferrite plus cementite, we call it as pearlite. Pearlite change from austenite at 0.76 weight percentage of carbon in iron to form eutectoid steel. As you can see in this drawing, we can see a layer of cementite and layer of ferrite, but we cannot see any proeutectoid. Later on in hypo and hypereutectoid, we will find proeutectoid of either alpha ferrite or cementite. In this figure, you can see photomicrograph of eutectoid steel showing the pearlite microstructure consisting of alternating layers of alpha ferrite, which are thick layers, light phase, and cementite, which are thin layers, most of which appear dark. At composition of carbon 0.76 weight percent of carbon in iron, we can see the transformation of austenite. This is the microstructure of austenite, which is in FCC. When the cool down process drop the temperature below 727 degrees Celsius, the microstructure changed from austenite into pearlite, eutectoid steel. This is the drawing of pearlite. To draw Pearlite microstructure at Eutectoid composition, you need to draw a lamellar structure between alpha ferrite and cementite in layer. The layer of alternating phases or lamella in pearlite are formed for the same reason as layered structure of eutectic structure. It is because of redistribution of carbon atom between ferrite and cementite by atomic diffusion. The pearlite exists as grains, often termed as colonies. Below 727 degrees Celsius with carbon composition less than 0.76 weak%, we will found Hypoeutectoid microstructure. We take example at this composition. The composition is less than 0.76% of carbon content in iron, so it will form Hypoeutectoid steel or Hypoeutectoid microstructure. At this composition, the austenite will have slight change in microstructure. From austenite, it will form ferrite plus austenite, where the formation of ferrite is in proeutectoid ferrite. You can see the proeutectoid ferrite or the ferrite will form in the grain boundaries of austenite. Later on, when we further cool it down, the proeutectoid alpha or proeutectoid ferrite will come bigger in the grain structure or grain boundaries of austenite. So please remember, the grain structure or the grain boundaries for hypoeutectoid steel is large due to proeutectoid alpha had become bigger in the grain structure or the grain boundaries. Later on, when we further cool it down below 727 degrees Celsius, it will fully form hypoeutectoid steel or pearlite structure for hypoeutectoid. You can see the proeutectoid ferrite or proeutectoid alpha in the grain boundaries had become large, and then the cementite and ferrite is in lamellar structure. You need to know the difference between eutectoid alpha or eutectoid ferrite with proeutectoid alpha or proeutectoid ferrite. Eutectoid alpha is the lamellar structure layered with cementite, and proeutectoid alpha is the alpha or ferrite in the grain boundaries. Ferrite that is present in the pearlite, and proeutectoid is ferrite that is formed above eutectoid temperature, or it is pre-eutectoid. And for proeutectoid, it formed in the grain boundaries of austenite. To find weight fraction of ferrite and weight fraction of austenite, and also weight fraction of cementite, you can watch my video on 5-step solving binary phase diagram, where I teach you guys how to use lever rule. The steps are the same. To find the weight fraction, you need to draw a straight line from point until the straight line meets any line in the phase diagram, divided by overall line. Below 727 degrees Celsius and with carbon content more than 0.76 until 2.14, we will find hypereutectoid steel. For Hypoeutectoid steel, we take example at this composition. This composition is having carbon content more than 0.76 weight% and less than 2.14 weight% of carbon content in iron. It starts as austenite, and then below this line, the proeutectoid cementite will start to form in the grain boundaries of the austenite. After we cool it down below 727 degrees Celsius, all this, we will get the proeutectoid cementite will form a grain boundaries which is slightly larger than the original grain boundaries. It is formed from cementite. So the grain boundaries is formed by proeutectoid cementite, and then we have lamellar structure formed from eutectoid cementite and layered with alpha ferrite. Once again, to find the weight fraction, please watch my videos on the 5-step solving the phase diagram. The step is the same. The difference is on the microstructure produced. Before we end this video, I want to remind you, please watch my video on eutectic microstructure so that you can compare with eutectoid microstructure. And the side note, please check on grain boundaries that form in eutectic and compare with grain boundaries that form in hypo and hypereutectoid. If you compare them, you can easily see their difference. I hope you clear with my content. We will meet again in next video. Thank you. Have a good day.